We're going to be taking a look at inverse functions. An inverse function is often thought of as an opposite function, but more specifically, it's an undoing of another function. You already have a lot of experiences with inverse operations. For instance, addition and subtraction are inverses of each other. Same with division and multiplication. Sine and inverse sine. If f of x does, f inverse undoes. So what you're probably noticing is that we have an exponent that is -1. In the context of functions or operations, whenever you see an exponent of -1, it means inverse. It does not mean reciprocal. That's a very important distinction. So here are some themes with inverse functions. So some themes are graphical, some are algebraic. Some of them are both. When transforming a function into the inverse, the graphs and points are reflected about the identity line. Y is equal to 0. So the identity line y is equal to 0 is actually a line with slope 1 and a y-intercept of 0. Some of the themes that will hopefully become apparent to you when we're transforming a function, when we're transforming a function, the points and the function are reflected about the x-axis. Another interesting feature is that the x's and y's are switched. And f of x and f inverse of x are inverse functions of each other if and only if f composed of f inverse of x is equal to x, or the f inverse, the f inverse composed of f of x is equal to x. So I'm going to task you with something that's going to hopefully reveal a characteristic or some characteristics of inverse functions. We are going to first graph the identity line. So I'm going to graph the identity line as this dotted line. What I would like you to do is I would like you to graph all the points on f of x in one color. Graph all the points on f inverse in a separate color. We're going to do so on this graph, and we're going to see what we come up with.